Good morning. Welcome to today's edition of Postgres Pulse, where today we're going to be talking about corruption. This weekly Pulse entry focused on something we've been seeing a time or two with respect to index corruption, and we've grabbed a few questions from both Stack Overflow and customer inquiries to couple all of this together. I'm your host, Jamie Watt. With me is Josh Heyer, EDB developer advocate, who some of you may know in his past life as a Stack Overflow rockstar, and of course the Postgres talent, Bruce Momsen and Vibhor Kumar. For those of you joining us for the first time, the goal here is very simple: to help you wherever your Postgres might be. We spend a great deal of time interacting with our customers on Stack Overflow, on PostgreSQL.org, and of course within our actual interactions and cases themselves. Pulse is a byproduct of this effort, with a weekly blog on trending issues, as well as our live cast here every Monday at 11 a.m. Eastern Time. Remember, this time is for you, so if you have any questions, and they're less about the meaning of life and more about Postgres, let's hear them. You're able to ask them before each session by tagging Postgres Pulse, or emailing us at postgrespulse@enterprisedb.com. But you can post them in the Q&A and ask them live here as well. If you do pose a question, we'll take it and unmute you so that we can talk live through whatever question you might have. And we have only two requirements, both for the question as well as, of course, the duration. Please be civil and please abide by the Postgres Code of Conduct. So, corruption. Ajay Patel and Dipanshu Sharma put together a piece on index corruption and how challenging it can be to ferret out its impact to your overall performance. And you can check that out on the Pulse page. Our first question actually is somewhat related to this. And I believe we've got that here queued up in our Q&A. The question itself was, after upgrading from, do we have that live?
Should be live.
Great, okay. The question was, after upgrading from 9.3 to 10 in Postgres and Ubuntu 14.04 to 18.04, having an issue with index corruption. Now, when we look through this, obviously two variables have changed relative to both Ubuntu and the major versions. But is there anything that jumps out to either you, Vibhor, or Bruce with respect to what could be coming into play here? Vibhor, how about yourself?
So clearly you can see there is a major version upgrade, right? From 14.04 to 18.04. It means a couple of things. One is that it could be a file system change, or it could be libraries which PostgreSQL uses to get the data, right? And those two are the things which I can see clearly is changing between these two major versions of Ubuntu. And I think if you're not using the ICU, right, then it could be possible due to change in the glibc, your indexes are corrupted, right? Now, whenever we see this kind of issues, we don't directly ask people to jump into any doing some activity. Always the best practices is that you take the backup of your data directory. If you see a corruption, don't mess with it, right? Because it would help us to find out the cause. And then after that, involve expert who can look into this problem. I think this is just only a index corruption, right? So your data may be safe, but your indexes are corrupted. Index corruption can be recovered many ways. You can actually do a reindex on the table, and there are many options available for you. But if this index is really playing a major role for like enforcing the constraints of foreign key in the database, right, then it may be a problem. It may create some other corruption of the problems. So you need to be very, very careful. So yeah, as I think I mentioned, whenever a corruption issue comes, we always ask people to step back, take the backup of a database, try to find out the cause of the problem, right? It could be a library issue when you're migrating from one major version of the Ubuntu to the another major version of the Ubuntu. And after taking the backup of your data directory, maybe just shutting down the system, taking the backup, and then looking into the problem or involving the expert is always the best idea to do. In case your data is not very important, you can either restore your logical backup, the old backup which you have taken, and continue further. But in case if you want to recover your data, right, then experts would be able to help you in that case.
Okay, great. Now, is this something that we typically see when you're looking at major version changes? I know that there's some perpetual dependencies or challenges we've had with glibc versions in the past. Is this something that persists today? Bruce, I'd like to kind of get your thoughts on that.
Yeah, I mean, you would think that language is language, right? I mean, nobody's adding new German letters or German, whatever. Even Armenian, which is what I am, they don't add new letters, right? We got a fixed number of letters. So you'd think that once the system has defined the letters for the languages and the order of the letters, that would remain the same. And even if you upgrade glibc or the operating system, that kind of dependency, which Postgres is using glibc, unless again the ICU library is compiled in, Postgres is using glibc to order its indexes, and you'd think, what can go wrong, right? But there are cases where it does change. German is one of them I'm most familiar with in terms of an official ordering of how letters should appear, because German has like a symbol for a double S and how those should be officially ordered within government documents and stuff like that. And those rules are changing occasionally. And when those rules change, the database is the same way we are database, with the same way the operating system updates the time zone database. It'll update its collation to match the official ordering of whatever language it's supporting, or it may be a bug of something they hadn't considered before and now they're fixing. And in most cases that doesn't matter, because you're running sort, you're displaying the data. If it displays differently, that's not usually a problem, right, for most applications. But databases are kind of unique because they're taking the sorting that's in the operating system in glibc and they're making it permanent, right? They're permanently storing the sorting it got at a certain point in time into a physical file. And if the rules change in the library, right, it no longer matches the physical order it used in the past, and you start to get weird results. So we do have, fortunately, a tool called AM check in Contrib, which will actually go through in a B tree and make sure that the index matches your collations in either ICU or glibc. So that would probably be the first case I would look at in trying to determine, was it a library collation change that actually caused this problem? In most cases it is, and most cases the solution is just to run reindex and reindex it. The nice thing about the ICU library is we do have detection. So if the version of the collation changes, you'll get a message. And also, starting Postgres 13, we'll even use the glibc version as a way of getting a version of that index. So we'll warn people if we have an index whose glibc version at the time it was created is different than what it was, what it currently is. So a lot of it's detection, because the solution, of course, is to reindex. But it's not a catastrophe. It's usually just a question of taking some downtime to run reindex on each database. You can get fancy and only reindex the indexes that use columns that are dependent on collations. That's an option. And I'm sure you can find a script somewhere to do that. But that's pretty much probably what's going on in this case.
Okay. So it sounds like we are making some changes, at least to improve the foresight to whether or not someone's going to run into that problem while they go through those upgrades.
Correct.
And like you said, the outcome of that is really just to ensure that they know that they have to reindex.
Correct.
Yeah.
And I think in that space, right, PostgreSQL community, actually, they have added a lot of new capabilities in the Postgres. One of them is the page checksum, which got added in the PostgreSQL 9.6, I believe. And then mcheck, as Bruce mentioned, right, helps you to look at the indexes and detect any kind of a corruption. And with that, community is also working on called heap check. Heap check would be able to tell you any corruption into the data files, and if there is any corruption around the consistency of the database itself. So community is really moving forward in providing all those capabilities in the Postgres, which can help you to detect any kind of a corruption or issues in your database.
Okay.
And that being said, there's also some kind of best practices which we recommend our customers to follow. Like for example, if you're taking the backups, right, you would like to make sure that you have a system which can verify, validate your backup for any kind of a corruptions, or always recommended to take your PG dump, logical backup of your system to verify or validate any kind of inconsistency in your database. So you should actually try to automate all these things in your environment to make sure that there is no corruption. Or if there's any corruption, it should be detected immediately and you should take necessary action.
I think we've talked about some of those backup practices a couple of episodes ago as well. So
Correct.
together nicely. Okay, great. Thank you. We've got an additional question out there that we had pulled forward, and the abbreviated version of it was, my toast tables are showing corruption after my laptop fell asleep. His laptop was the actual platform on which they're hosting the database. How can I fix a missing chunk number?
Okay, let's see, what is it? So this is,
so it looks like they basically had it running on an external hard drive, their laptop, right? And then the laptop went to sleep. Apparently, it thought the server was still running. After running a number of index commands or reindex commands, they're hitting an issue in their toast table in PG Toast, right? And I think PG Toast 2618, that's tied to a specific portion of the database, right? PG rewrite.
okay, yeah. So PG rewrite is actually a very important table. And if this got corrupted, it means it could be possible your views and other views or materialized view, whatever you have, right? Those may also got corrupted. And it may impact your database. It may be possible that you may not be able to view certain data because if you remember, a lot of drivers or the connectors, they try to use views to determine what are the tables you have, right? And again, this looks like a bigger issue. Recommendation here, I mean, again, so let me step back and explain a little bit what people are seeing in the toast table information here, right? So PG underscore toast is a toast table of a specific main table. So whenever you create a table and there is a specific column which cannot fit into the main table, PostgreSQL automatically creates a one toast table to keep those information for you. Now PG toast, the naming convention which PostgreSQL follows is PG underscore toast underscore rel ID. And the rel ID tells you whether the particular toast table belongs to which table in the PostgreSQL. So here it is PG rewrite, right? And it looks like the chunk, the toast table which got corrupted belongs to PG rewrite, and the PG write, it means PG rewrite is corrupted, and you may not be able to access specific information or data. And PG rewrite is a key table in the PostgreSQL. It's a catalog table. So if you see this kind of a problem, again, the best practice is to stop the database, take the backup, involve your expert to help you to recover a certain amount of data. But in case if this table, or if the database is not very important and you have a logical backup, you can either remove the whole data directory and restore your database using the logical backup. And again, you can see here, the main problem is the disk, this external disk on which person is running the data directory or keeping the data directory of the PostgreSQL. So
you
again,
can totally see this happening for like a dev workstation, right?
yeah, I've seen this kind
Get
of
my
issue.
company issued laptop with its 500 gigabyte hard drive. I got to
Yeah.
have a production database. Okay, plug in an external hard drive.
Which is not recommended, because you can think about the situations where here you can see that, right? Your data directly on the external drive and your PostgreSQL processes are running on the main laptop. And in case the data directory is pretty much vanished, then you lose your data or you corrupt your whole data directory itself. So it's not recommended at all. It's
So
better to,
hopefully for critical data, you would have a
yeah,
proper redundant, high reliability setup somewhere that's not going to suddenly disconnect drives or cut power. But
yeah,
sometimes, you end up in situations where you're just trying to make it work. So ideally,
that
though,
is
in this situation, if the data isn't critical, you can just restore from backup
correct. Yeah.
it and not worry about trying to patch this up. It's going to be a bigger pain in the ass than it is.
Yeah. And thank God this is not happening in the production environment, because PG rewrite corruption is really a big issue. And that's why we always recommend person to use, or our customers to use a one module called PGCat check. It actually helps you to detect any kind of a corruptions into your catalog table. So, so yeah, I mean, this is a critical thing here. If your catalog tables are pretty much corrupted, that's a big issue. Recovering those data is a problem here. And that's why we always recommend to involve right people in this case, if you really want to recover some of the data.
Okay, great. Thank you. I think that actually brings up a bigger point, and I had mentioned a few minutes ago, we've talked about backups in the past and the best practices associated to that. There was a question that we actually had from a couple of different customers over the last few weeks associated to a recent blog post about Postgres' strengths and weaknesses. And the question was, should I be considering logical replication instead of streaming? Currently, I'm using streaming. I've got a delayed replica, so I can catch things at least within a certain window. But having recently read a certain post, the question is whether or not logical replication is actually a lot safer and exposes you less to disk corruption than what streaming produces. What are your thoughts on that, Bruce?
Well, database is always a funny piece of software because it's got such high durability requirements. I mean, most people, if they're in a word processor and they lose their laptop goes to sleep, they're kind of like, all right, maybe I lost some data and I'll have to retype it or whatever. The database is this incredibly complicated thing that's all hooked together. And if anything doesn't look right, it just kind of freaks out, right? And that's what the error the person was getting with the toast table. It's like, this doesn't make sense. I'm not even going to try and fix it. I'm just going to give that person an error because, again, we want to give durable, accurate data, or we don't want to give any data, right? And that's a different hurdle or different level of reliability than you would expect from a normal application. That,
Sure.
okay, the email didn't go, let's just resend the email, right? or resend the web page. Okay, it doesn't look right. Oh, that's okay, right? That database doesn't do that. So that's why this drive thing is a problem. You have to have stable storage underneath it. Now, normally, if it wasn't an external hard drive, then the laptop would have known the drive was going to be powered down. It would have flushed the memory to the disk. It would have flushed the disk cache to the magnetic disk, and then it would have shut down cleanly. You wouldn't have gotten the corruption. I have a feeling because it's an external unit, the laptop operating system doesn't really understand how to flush that properly, or the thing just ignores the flush command. I've seen devices that just, you say flush the disk cache to permanent storage, and it's like, okay, I'm done, and it doesn't do anything. So that's probably why the corruption happened. You have to have those accurate layers down there. Now, the idea of using logic replication, there is some value to it because you're not sending, typically when we're doing binary replication, we're saying open this file, write these, seek to this offset, write these bytes. And you just do that over and over again. Very fast, very low overhead, very reliable. And you have two identical binary copies on the two sides. With logical replication, you're sending, here's a new row, and you're actually constructing the row, and the row's being inserted, and the indexes are being updated independently on that side. There's a whole bunch of stuff that goes on differently for logical replication. And there's a sense that because you're not binary copying things, if something was to get binary corrupted, I'm less likely to have a binary corrupted on the other end. And there is, again, there's some value to that, but there's also a lot of disadvantage because, again, logical replication is per table. It's not for the whole database, the whole cluster. There's a lot more overhead of replaying on the logical side. DDL doesn't come across the same. And you're really adding a lot of potential problems to try and avoid this little case where the bits get out of sync. So yes, logical replication could be an option for that, but I would not recommend it because I think logical replication brings so many additional problems, not only the overhead, but keeping the schemas synchronized and sort of having to, there's just a whole boatload of problems. And you don't want to trade one problem for 4 problems. And that's really what you're going to be doing if you're using logical replication just to try and avoid this hypothetical thing. You're better off, frankly, making sure that your hardware is good, making sure that you're running, smart mon or smart tools to monitor any kind of errors that the storage sends, monitoring your kernel logs to see any kind of unusual memory errors or anything that looks like something's not working right.
This is another situation where you really need to define your threat model before you go jump into solutions.
Yeah, right? And it just logical replication is just kind of going, it's sort of like saying, I'm worried I'll run out of gas, so I'm going to fill my back seat with gas cans. Well, you're not going to run out of gas, but you got a lot of gas cans in the back there, and that might be a problem, right? So
correct.
You kind of want to avoid that. Again, do the simple things like monitoring, smart tools and making sure you've got durable storage. We have a disk checker Perl script referenced in the Postgres docs that helps you determine if your storage is durable. There's a whole bunch of stuff that really should be done before you go down that logical replication route. And most people, again, find that that's a much better use of time and a better outcome.
But if you were coming at this from the perspective, you knew there was a good chance that your database was going to get corrupt, that your indexes were going to get corrupt, that something was going. Say you're trying to build a cluster from a pile of old laptops and external hard drives sitting around. I mean, maybe that's what you want to do, and you're pretty sure stuff's going to go south. Is logical replication a safer option in that scenario where you are pretty damn sure corruption's going to creep in?
Yeah, but the corruption is going to happen anywhere, right? It's going to be heap rows that get pulled when you read them. It's going to be any kind of crash recovery you have. You're really building on a pile of sand. I don't think logical replication is going to really solve that in any meaningful way. If somehow logical replication could be done where it didn't rely on anything else, it didn't rely on the memory and the disk and all that other stuff, I guess. But it's you're really just taking
if you corrupt your logical rows being sent across the wire, they're still corrupt.
Yeah, the heap is still going to be corrupt. If
the WAL file is corrupted, the decoding will not work properly.
Yeah, the WAL file itself could be corrupt, right? Because the
logical rows are still going across the dead.
Logical rows are still going through the wall, right? Yeah. We've got records in there. How long is the wall record? I mean, there's a whole bunch of stuff there that's going to be
correct.
Go south.
And second, it could be possible that your target machine might be corrupted because you also have the same problem could happen there too, right? So it's not really a fail safe or something which you can think about, okay, this would help me to find out any corruption or would help me to avoid the corruption at the file system level or disk level.
So that kind of brings us back to the original solution that the individual had been asking us about, that having streaming replication is probably your best overall generalized approach to it. And as long as you've got a delayed standby, then you're at least adding a layer of resiliency, as long as you can understand the corruption when it occurs within a specific window. Another question that actually was very much in line with that one was they were running that same configuration. They did have a master, a standby, and then a delayed standby. But the question that was being posed was, can I actually use two different methods or two different two different modes of replication, where I'm doing streaming to my initial standby and then logical replication downstream of that. Is that something that is being considered for either Postgres going forward, or just in the Postgres community in general at this point?
They want to do belt and suspenders. They want to make sure that they get both types of corruption. I mean, that they're safe from either type of corruption.
Right. So Vibor or Bruce, are you aware of?
I think Vibor has the answer to this one.
Yeah, so first of all, you cannot create a logical standby from a physical standby. Okay, that's not really pretty much supported, and community is still working on providing some capability so that you would be able to create a standby.
Okay.
But that's not
On
really.
that, though, or some flavor.
Yeah.
Okay.
Yeah, but and second, this is not really solving your problem for corruption or helping you to recover from the corruption problems.
Sure.
Because overall, what you're doing, you're just moving things from one place of detection to the another place and another place to another place, right?
Yep.
Overall, if your, let's say, logs are corrupted at the primary side, right? The standby which you have may get the corrupted block too, right? From there, if you want to, and let's say in future, if the logical standby will be supported, right, from the physical standby, again, it's not solving the problem, because you will again end up on the same problem where, if let's say if your WAL file is corrupted, then and a table is corrupted and logical decoding may not work properly to send you the right statement on the logical standby side, right? So it's not really solving any problem altogether. What you can do, actually, you can create a multiple level of checks on the primary or standby side to find out, detect those corruption quickly and avoid those, or or stop there itself, so that the corruption should not spread across other platform, other systems. So yeah, I mean, what community is focusing on, I mean, Bruce can of course chime in here or can add some color here. Community is focusing on providing a capability to detect those corruptions, right, and stop it there. So for example, page checksum. So whenever it finds any corruption, it stops there. It doesn't really allow users to access other information or perform any operations, right? So those kind of capabilities are coming in the PostgreSQL. Detection-wise, there will be some extra tools available for the users to detect, scan their heap or scan their indexes to find out any level of corruption, stop there, and plan it accordingly.
Okay, great. All right, well, I think that actually brings us to the end of our questions. Again, while we're wrapping up, certainly if anyone has any additional questions, feel free to post them now. But I want to thank everyone for joining us today. Please remember, you can follow up with any questions that have been posed here or any that you didn't get a chance to pose on Twitter, LinkedIn, or directly with the team, again, at postgrespulse@enterprisedb.com. You can find links to both this session and our overall YouTube playlist of the prior 6 sessions, as well as a link to our blog series on the Postgres Pulse page on our website, which is edb.com or enterprisedb.com/postgres-pulse. Keep an eye to our topics for next week. Next week, we're going to be talking about PG Badger and how log analysis can help you spotlight common problems in your checkpoints, vacuums, and other. And again, thanks to all of the panelists for your time today. And thank you to everyone who joined us, and appreciate your time. Take care, everyone.
Thank you.